This is Prabha Verma here with my next video of class 10th of the chapter Quadratic Equations. We have already discussed a bit about quadratic equations in the chapter of polynomials. But before I proceed to that, let me come to the first and the foremost thing about a quadratic equation, that is the standard form of a quadratic equation. When I say the standard form, what I mean is ax square plus bx plus c equal to 0 is called as the standard form of a quadratic equation where a, b and c are all real numbers and a can never be equal to 0. Why I am adding this condition? A can never be equal to 0 because if a becomes equal to 0, then over here the x square term becomes 0 and this equation stops being a quadratic equation. With this term becoming 0, it will reduce to a linear equation. So the first and the foremost thing about this chapter is the standard form. So ax square plus bx plus c equal to 0, where a, b and c are real numbers and a not equal to 0 is called as the standard form of a quadratic equation. This is at times asked as a one marker. This is at times asked as a one marker, that is, write the standard form of a quadratic equation. Next, you have already learned how to find the zeros of a quadratic polynomial in the chapter of polynomials. Now, whether I say zeros of a polynomial or I say roots of a quadratic equation, this is again a quadratic polynomial, and roots of a quadratic equation, they both mean the same. Basically, when I say roots or the zeros, it means that value of x which when you put it back in the given equation, it satisfies it. Right? Now, you have also learned the graphical representation of these quadratic polynomials. Though the graphical plotting or representation of quadratic equations is not in your syllabus, you will not get to plot it. But you should know about the graphical representation of these quadratic equations. Now, whenever we plot the graph of a quadratic equation, we always get a parabola. The parabola is either like this or it is like this. This looks like a U. Now, how do you know whether the parabola will be open on the upper side or it will be open on the lower side? Now, this is decided by again your equation. I have this equation. Now, the value of this a, that means whatever is multiplied to x square, that decides whether your parabola will be opening upwards or downwards. Now, if a is positive, that is if a is greater than 0. When I say a greater than 0, it means a is positive. Then you get this kind of a parabola. When a is less than 0, this implies a is negative. Then you get this kind of a parabola. So basically it is what the type of parabola is decided by the sign of a, that is whatever is multiplied to x square decides what kind of a parabola you're going to get. Now, coming down to the zeros graphically, I take my first graph over here. Now, the first graph over here, if I take, suppose this is my graph, this is the x-axis and this is the y-axis, right? Now, when I plot the graph over here, suppose I get a graph like this, or I might get a graph like this, either of this, or I might get an inverted graph where it is cutting. Either of these cases, the graph is cutting the x-axis at two distinct points. The graph is cutting the x-axis at two distinct points. That means whatever the value of x over here and over here, they are the two zeros of this particular quadratic equation. Similarly, over here, whatever the value of x is here and over here, these are the two zeros of this particular equation. So in either of these cases, it has two zeros. It has two zeros. Second case is, I have this. It can intersect at one single point, like something like this. Again, in both these cases, the parabola, in both of these cases, the parabola is intersecting the x-axis at a single point. That means the same value is over here. So in this case, we said it has 1, 0, but the same value is repeated. This can be explained with an example like x minus 1 whole square equal to 0. This is a quadratic polynomial undoubtedly. When I open the bracket and I solve it, I will get x equal to 1 comma 1. So this kind of a graph is that value where the same answer is coming two times and we say it has 1, 0. Coming down to the third case, when I plot the graph, I might get either this kind of a parabola or this kind of the parabola. In either of this, it is not touching the x-axis or it is not intersecting the x-axis. That means it has no zeros over here. Now, if I have to explain you this with an example, I take a quadratic polynomial like x square equal to minus 25. Now over here, if I have to find the value of x, I'll have to take this 2 on that side. That means when I take this 2 on that side, this becomes a square root. But you also know that under the real number system, under the system of real numbers, you cannot find the square root of a negative number. So in this case, we say that it has no real roots. It has no real roots. So there are no zeros over here. So basically I've discussed three cases over here. The first case was two zeros where I get two distinct values. Here both are positive, here one is negative, one is positive. In this case it has a single zero which is a repeated zero, and in the last case it has no real roots because it is not intersecting the x-axis. So I am getting either 0, no zeros, 1 0 or 2 zeros. If I have to compile all these three answers, I call it as at most 2 zeros. I call it as at most 2 zeros, and this statement which I have written over here, at most 2 zeros, is again a one marker question. I can ask you how many zeros does a quadratic polynomial or equation have? So the answer is it has at most 2 zeros, right? Now coming down to the next concept in this chapter, if I give you a polynomial and I ask you to check whether it is a quadratic polynomial or not. So how do we do it? Now if I take an example over here, suppose I take this example over here. I have an equation like x minus 2 whole square plus 1 equal to 2x minus 3. I give you this and I ask you to check that whether it is a quadratic polynomial or not. So what do you have to do in this? You have to open the brackets. You have to open the brackets. So when I open the bracket, I'll get x square minus 4x plus 4 plus 1 equal to 2x minus 3. When I solve this and transfer everything to one side, I will get x square minus 6x plus 8 equal to 0. And this is undoubtedly a quadratic equation where your a is 1, your b is minus 6 and your c is 8. So it is satisfying all the conditions of the standard form of a quadratic equation. So ultimately, what decides whether it is a quadratic equation or not? Compulsorily, it is important to have the x squared term. You might have the middle term, you might not have. You might have the last term, you might not have. But till you have the highest power as a square, as 2, it remains a quadratic polynomial. Even if I write something as 2x square, this is also a quadratic polynomial, though over here your a is 1, your b is 0, and your c is also 0, because there is no term of x and there is no constant term over here. So even this is a case of a quadratic polynomial, this is also a case of a quadratic polynomial. Now coming down to finding the zeros of a polynomial, very quickly I take you through what you've already done in polynomials. If I give you a quadratic polynomial, for example, 2x square minus 5x plus 3 equal to 0. I ask you to find the solution, I ask you to find the zeros, or I ask you to find the roots. All the three mean the same, that you have to solve it by splitting the middle term. Obviously, the first step is you write it in the standard form, the highest power, then the x term, and then the constant term. Now, what do you do to split the middle term? You multiply this 3 by this 2. That means you multiply the constant term by the coefficient of the x square term. So when I multiply, I get 3 into 2, I get it as 6. Now I have to find all possible factors of the 6. 1 into 6 gives me 6, right? Minus 1 into minus 6 also gives me 6. Minus 2 into minus 3 also gives me 6. And 2 into 3 also gives me 6. These are the various possibilities I get to get an answer as 6. Now out of these possibilities, how do I decide which one is going to fit in over here? Now what the condition is, when you multiply the two factors, you should get 6, and when you add them, you should get the middle number. The middle number over here is minus 5. Now when suppose I take 1 and 6. 1 into 6 is giving me 6, but 1 plus 6 is not giving me minus 5, it is giving me 7. So I rule it out. Next is minus 1 minus 6. When I multiply them, I am again getting a plus 6, but when I am adding them, I am getting a minus 7, but I require a minus 5, so I cancel them out also. Next I come to minus 2 minus 3. I multiply them, I get plus 6. I add them, I get minus 5. So this is my required answer. So I write it over here, 2x square minus 2x minus 3x plus 3 equal to 0. What have I done? I have split my middle term into two factors. Next step is I combine these two, and I combine these two, I take out common. So first two terms have 2x as common, so it becomes x minus 1. Minus of 3 I take out common, again x minus 1 equal to 0. Now what you have to remember over here in splitting the middle term is these two brackets will always be identical. Whatever you get over here in a bracket, you will get the exactly same thing over here also in a bracket. In case you are not getting, you have made a mistake somewhere. Now if I take both these terms, I have common x minus 1. So I take out x minus 1 common, and what is left from here is 2x. What is left from here is minus 3 equal to 0. I equate the first bracket equal to 0. I get x equal to 1. I equate the second bracket equal to 0. I get x equal to 3 by 2. So I get my final answer as x equal to 1, x equal to 3 by 2. They are the two zeros of this particular quadratic polynomial. This is a very important chapter from the point of view of board exams. So you should know the basic concepts as well as all the detailed things that we're going to cover in my further lectures and videos. Thank you.